question number 1. First, we need to collect the data from the question. For class A, n is equal to 40, average is equal to 75, standard deviation equals to 8. While class B, n equals to 35, x equal to 78, standard deviation equals to 10. Step 1, we need to determine null and alternative hypothesis. In this case, H null, mu1 equals to mu2, while H alternative, mu1 is not equal to mu2. Therefore, it is a two-tailed test. For step 2, we need to calculate the test using the formula given. So, the answer that we got is negative 1.420. Next, we need to calculate the critical value. Since this is two-tailed test, the significance level need to divide with 2. So, the answer is plus minus 1.69. For step 4, we need to justify. So, because of z value is equal to negative 1.20 falls in the non-critical region, we need to accept HO at 0.05 significance level. For step 5, we need to make a conclusion. So, H now is mu1 equals to mu2.
We have two groups of athletes. Group A use method 1 with a mean sprint time of 12.3 seconds, a standard deviation 0.5 and 20 athletes. Group B use method 2 with a mean sprint time of 12.1 seconds and a standard deviation is 0.4, also with 20 athletes. The significant level used is 0.01 and this is a two-tailed test. First, we set up our hypothesis. The null hypothesis states that the mean sprint time of the two groups are equal. The alternative hypothesis, H1, states that there is a difference between the two means. Next, we calculate the pool standard deviation using the formula. So, after substitution, the pool standard deviation is 0.4528. Then, we calculate the t-test statistic using t-test formula. By substituting the value, we get t equal 1.397. With 38 degrees of freedom, the critical t value at the 0.01 significant level for a two-tailed test is plus minus 2.712. Since our calculated t value 1.397 is less than 2.712, it falls inside the non-rejection region. Therefore, we fail to reject the null hypothesis. This means there is no significant difference in the mean sprint time between athletes trained using method 1 and those trained using method 2. Although there is a small numeric difference, it is not statistically significant at the 0.101 level. In conclusion, based on our data, both training method appear to produce similar sprint performance results. That's all.
Now, let's move to question number 3. First, we need to compute the various terms, which is 100 divided to 15 equal to 2, and for type B, 144 divided to 45 equal to 3.2. So, the standard error equal to 2.28. Substituting gives z equal to negative 4.39. For a two-tailed test at significant level 0.05, the critical value are plus or minus 1.96. Since negative 4.39 are more than negative 1.69, the statistics lies in the rejection region. The two-tailed p-value corresponding to z equal to negative 4.39 is approximately 1.13 times 0 negative 5, which is far smaller than 0.05, which strongly reject H null. This interval does not include 10 and is entirely negative, indicating that type S mean is lower than type B, mean by between about 5.5 mg and 40.5 mg. Finally, the standardized effect size using the average of the two population variants is roughly 0.91, which is considered a large effect. So, the difference is not only statistically significant but also practically meaningful. This conclusion assumes the samples are independent, drawn randomly, and that either the population are approximately normal or the sample size are large enough for the central limit theorem to apply.
I will explain about question 4. First step, we have to make a table that contains participants before and after. We also need to add a table for.
So how you want to get the DI value in the table is you can take the after value and minus with before value.
And table DI minus with the segment in power of 2. After that, we have to do a hypothesis. H0 is mut equal to 0 and H2 is mut non-equal to 0, because if we do hypothesis, H2 will always be opposite with H0. Second step, we will use a formula of segment D that equal to sum DI divided by N. So I got answer. My answer is 6.143. Next, we use a formula of SD equal to square root sum of DI minus with the segment power of 2 divided by N minus with 1. Other than that, we have to calculate DF because we will use the table. Why we use the table? Because the average of data is below 30. So the DF formula is equal to N minus with 1. Next is step 3. Step 3, we have to count the alpha level. So because we use the table, because the hypothesis is two-tailed, we have to divide the alpha level with 2. After we get the answer, we can refer to table 3 using amount of DF and alpha level we get. So step 4 is after we have referred to the table, we can draw the normal distribution table to see where the answer fall in. After that, we have see the conclusion. So for S4, value T 4.601 is fall in critical region because we can see at the table we have drawn before, and reject H0 at 0.05 significant level. So for S5, the answer we have to take the right one, that is mut is non-equal to 0.